everyone. In this video I explain graphs of trigonometric functions. Sine, cosine, tan, sec, cosec, cotan. Let us start. Let us start with the first function, y equals sine x. So this is the graph of y equals sine x. The graph passes through the origin. The maximum value is positive 1, the minimum value is negative 1. The graph is symmetrical about the origin, so the function is odd. The period of the function is 360 or 2 pi. So the function repeats itself every 360 degrees or 2 pi. The range, this is the range between the value of y. The value of y includes between negative 1 and 1. So it means any value of sine theta or sine x, so any value of sine must be included between negative 1 and the positive 1. Cannot be more than 1, cannot be less than negative 1. There is no asymptote for this graph. So this is the graph of y equals sine x. The second graph is y equals cosine x. The graph is symmetrical about y-axis, so it is even function. The period of the function is 360 or 2 pi, repeat itself every 360 or 2 pi. The range, the value of y, it's from negative 1 to 1. It means any cosine, any angle included between negative 1 and the positive 1. There is no asymptote. The third graph is the graph of tan. Now, this is the graph of tan. So, the graph of tan has no minimum or maximum, like cosine or sine, going to infinity and going to negative infinity. So, the range is r. But the period is pi, so the graph repeats itself every 180 degrees or pi. It is odd function because it is symmetrical about the origin. In graph of tan we have asymptote. So the graph does not intersect x equals pi over 2 or x equals 90, does not intersect x equals 3 pi over 2, does not intersect x equals negative pi over 2. It means the value of the function is undefined when the angle equals pi over 2, 3 pi over 2, or negative pi over 2. So the asymptotes at x equals pi over 2, negative pi over 2, negative 3 pi over 2, 3 pi over 2, and so on. Generally, x equals 2n plus 1 times 90 degrees, or x equals 2n plus 1 times pi over 2. So this is the asymptote in graph of tan. So remember, sine and cosine, they don't have asymptote, but tan has asymptote. The asymptote at x equals 2n plus 1 times 90 degrees, or at x equals 2n plus 1 times pi over 2. It means that the function is undefined when x equals any value of this. Now we study another graph. The fourth graph is cotan. The graph of y equals cotan, symmetrical about the origin, so it is odd function, the same like tan. The period is pi or 180, the same like tan. The range is r, so has no minimum or maximum, going to infinity up and down. But the asymptote is different. The asymptote in case of cotan, when x equals 0, when x equals pi, when x equals negative pi, so the function is undefined when the value of the angle is any one value of this. Or x equals 180 n degrees, or x equals pi n. N equals 0, 1, 2, 3, and so on. So this is the graph of cotan. The fifth graph is y equals sec x. Look at this graph. It is even function because it is symmetrical about y-axis. The period, the graph repeats itself every 360 degrees or 2 pi. What about the range? That range, the graph, it's from 1 to infinity, or from negative 1 to infinity. So the range is y less than or equal to negative 1, or y greater than or equal to. Also in that graph we have asymptote. The graph does not intersect x equals pi over 2, It means the sec pi over 2 is undefined, sec negative pi over 2 also is undefined, so that are asymptotes. So the asymptote when x equals negative pi over 2, 3 pi over 2, and so on, or x equals to n plus 1 times 90 degrees, or x equals to n plus 1 multiplied pi over 2. This is the graph of sec x. The last graph is the graph of y equals to sec x. The graph is symmetrical about the origin, so the function is odd. It is symmetrical about the origin. The period is 360 or 2 pi. The graph repeats itself every 360, so the period is 2 pi or 360. The range, it is the same like sec y less than or equal to negative 1, or y greater than or equals 1. The asymptote is different. The asymptote at x equals pi, 2 pi, negative pi, and so on. It means that the value of cosec is undefined when x equals pi, 2 pi, negative pi, and so on. So the asymptote at x equals negative 2 pi, negative pi, 0. Also x equals 0 is asymptote, pi and 2 pi. Or x equals 1, atn, where n is an integer, 0, 1, 2, 3, and so on. X equals pi n. So this is in terms of degree, this is terms of pi. I hope you understand this part of trigonometry. Thank you.